This geometry question on the Math SAT looks hard, but is actually really easy. Triangle ABC is similar to triangle DEF, where A corresponds to D and C corresponds to F. Angles C and F are right angles. If tangent of A equals square root 3 and DF equals 125, what is the length of DE? So the first thing we can do is start by drawing each triangle, right? We have triangle ABC, where C is a right angle, so it's going to look like that. And then, a similar thing for DEF, where it's going to be D, E, sorry for that bad E, and F right here where F is a right angle, right? So from here we can draw on what we have. Tangent of A equals square root 3. And since tangent is opposite over adjacent, we can just write that tangent of A, or square root 3, equals opposite, which is the segment BC, over AC, right? Equals, we can also from here write in, we have DF equals 125, right? And we're looking for the length of DE. So BC corresponding with EF is going to have EF as the numerator, and then the denominator AC corresponds with DF, but since we know it's 125, we can just substitute that, right? So now we have EF over 125 equals square root 3, right? If we multiply both sides by 125, we're going to have EF equals 125 square root 3. Right? So we can just write that in right there, 125 square root 3. And now we're solving for the length of DE, which is going to be this hypotenuse right here. So what we could do is solve using the Pythagorean theorem, or we could recognize that this follows the rules of a 30, 60, 90 triangle, right? In a 30, 60, 90 triangle, your lengths are x square root 3, and 2x, right? And so since we have 125 as x, and then this EF as x squared root 3, the hypotenuse is going to be 2 times this shorter leg, which means that the answer for DE is 250. And that's going to be the answer.